Hello everyone. Today we're going to explain the network reference model. We need to understand how data is defined and how it is represented. Also, we'll discuss the concept and advantages of the network reference model. First, let's look at applications and data. When we open a web page, play a game, or watch a video online, we are actually using applications to generate data. What is information? Text, pictures, and videos are all various forms of information, such as text, pictures, videos, and other media. In this process, our computers cannot understand these pictures or videos. They can only understand numbers like 1010, but our equipment compiles them and turns them into something we can understand. In this process, we need to define how the data is generated. It has a standard. For example, if I want to send a letter to everyone, I write the recipient information, sender information, recipient address, and sender address. If there is no standard, the world will be in great chaos, and the same is true for our network now. It also has such a reference model. First of all, let's talk about OSI, which is a reference model launched by an international organization called ISO. It has 7 layers in total. Let's look at it layer by layer. From the bottom, the first is the physical layer, which defines the transmission medium and is a standard. The second layer, the data link layer, is used to achieve precise positioning. The third layer, the network layer, is used to achieve global positioning. If you want to find someone in the world, you must first know his name. Knowing his name is called global positioning. If I know who he is, but I want to know where he is in a certain city, in a certain country, then we need precise positioning. Then we say that the fourth layer is the transport layer, which means that during the transmission process, for example, brothers may use the internet to do many things, such as transferring a file or sending a video. I certainly don't want to download this video for 3 hours, or upload it for 3 hours, and then he tells me that it is damaged. So here you have to choose whether this thing is a reliable transmission. If it is an operation such as transferring files, we need reliability. If we talk about voice or video, we actually require its speed rather than its reliability. Then, we say that the above 3 layers are actually not the scope of our network engineering, but the scope of software development. Why? For example, we have a drawing layer here. If we use a social software, we may chat with classmate A, classmate B, and classmate C. Each chat window is actually a session. Secondly, in this process, there is a presentation layer. That is to say, when we are using a software. Now, you will find that it seems that we can use it on various platforms, such as PC, Android, or Apple. Each system can use a corresponding software. In this, the underlying compilation language and its representation method are definitely different, and the presentation layer is responsible for this. Finally, the application layer provides a window for people and devices to interact. In this layer, we can operate, which is the application layer. In this process, we only need to manage 4 of the 7 layers. Are we using the OSI model now? Actually, no. We are using another model, the TCP/IP model. How is it better than the previous OSI model? Why don't we use OSI? First of all, the OSI reference model is too detailed. However, it doesn't tell you better what each layer should do. It just tells you what I should design for this layer. When it comes to fiber optics, how can we design it better? There isn't a very good standard for that, so later on, the TCP/IP model was adopted. It comes in 2 versions. One is the standard TCP/IP model, and the other is the equivalent TCP/IP model, with one having 5 layers and the other having 4 layers. Let's first take a look at the 4-layer model. Whether it's the 4-layer or 5-layer model, you can see that the top 3 layers from the previous OSI model have been condensed into a single application layer. In this model, the standard TCP/IP model combines the data link layer and the physical layer from the OSI model into what's called the network interface layer. This division model is actually contrary to the description of the actual protocol, so an equivalent TCP/IP model that combines the TCP/IP standard model with the OSI model is proposed. Generally speaking, we can say that it has 4 layers, or we can say that it has 4 or 5 layers. So right now, what we're actually using is the TCP/IP model. However, when we talk about the second layer or the third layer, we're actually referring to the OSI model. For instance, when we mention second layer technology, we're talking about data link layer technology. And when we refer to third layer technology, we mean network layer technology. That's something everyone should keep in mind. If anyone wants to learn about Huawei certification technologies or wants to access the Huawei certification question bank, please message me privately. You can also leave comments below the video for technical discussions.